This is the first video for 6-2. And 6-2 all has to do with what we call the natural base E. So the natural base E, it's kind of explained here, but what you just want to think of is we have in math, so this is, I'm going to say similar to, there's some other special math numbers that are so special that we give them a letter to designate them, and one of them is pi. You should be very similar or very familiar with pi. So it's a decimal, an irrational decimal that goes on and on, never repeats. And then also in the first part of Algebra 1, we learned about I. Remember, I was the square root of -1. Also, we gave it a special name because it's one of those special numbers in math. So E is one of those also, or the natural base E. It's named after, the E comes from the mathematician who studied it, Euler or Euler, you'll sometimes hear his name called. And so if you put E to the first power, well, I want to show you first of all, it's on your calculator. I'll show you on both of them. Let's see, where is it on this one? So you see this button that says ln, that's the natural log. And then if you look right above it, it's always with that natural log, there's E to the x. So if I press second natural log, notice I get, it says E to the, and then if I just put 1 in there, I'm going to get this number, 2.71828. So that is what E is. So if you look at your notes here, it says E is approximately that 2.718 number, that decimal that goes on and on forever and never repeats. Okay, it can also be a function. So I can graph the function y equals E to the x. It's just like what we've been doing with these exponentials, right? Early on in 6-1, we did some graphing on functions like this, 2 to the x, or we did 1/2 to the x. This is the same thing. E, you can just think of it as a number. It's 2.71, but it's still just an exponential function. And this graph approaches this line right here. This is an asymptote, and that line is right at, see, you can see it's a little less than 3. It's right at 2.7. Okay, so don't get too worked up. It's just a number. Just think of it as kind of like 2.7. So when we have graphs of E, this kind of says everything in words. It's got a lot of words. I'm going to summarize it down here. These exponential graphs, just like you're used to, are either going to be growth. So remember, growth, as I move from left to right, it points up. And in this case, it's when the exponent is negative. So they have this general equation here. They're saying, hey, you might have a number in front, an A, and then you're going to have E to the Rx. So if R is negative, so I'm going to say R is negative, then you have growth. So when you have growth, R is, wait a minute, no, R is positive. Geez, positive for growth. If R is positive, then you're going to have growth. And over here, this is a graph of decay, because when we move left to right, our graph is approaching 0. And this is going to be R is negative. Now, what you can think of is the exponent is going to look negative. So this is the graph of E to the negative x. This is the graph of E to the positive x. So E with a positive exponent is going to be growth. E with a negative exponent is going to be decay. So think of the R as just the number in front of the x that if it's positive, you're going to have growth, and if it's negative, you're going to have decay. So I'm just going to do this example 1. Examples 2 and 3 I'm going to do in a separate video because we're going to graph those using decimals. But in example 1, all it's asking is tell whether the function represents exponential growth or exponential decay. So growth is going to be when the exponent is positive.